Okay, here we go. Did we get this one? Okay. So, the really big idea that we covered yesterday is kind of twofold. First of all, you learned how to plot and graph complex numbers. Okay. Second of all, you learned how to find the modulus, which is the absolute value, the distance it is from the origin. Third, you saw an example of how to place complex numbers in a trigonometric form. Okay. Now I'm going to take our answer from yesterday and show you one quick thing so you can understand how they relate. We had 2 plus 2i, you don't have to write this down, but we came up with 2 roots of 2 times cosine of pi over 4 plus I sine of pi over 4. Is that correct? All right. These look completely different to you. They look foreign. I understand that. I'm going to show you how they're exactly the same. What is the cosine of pi over 4? 45 degrees is pi over 4. What is the cosine of pi over 4? Root of 2 over 2, right? That's from your last test, right? Plus I times what's the sine of pi over 4? If I have a 2 in the denominator, I multiply through by 2, what happens? Just cancel, right? And you end up with this expression. Root of 2 times root of 2 plus I roots of 2. Let's distribute. What's the root of 2 times root of 2? See how they're the same? They're identical. So you should be able to convert back and forth between complex as well as, complex as well as a trigonometric form. Okay? So let's try the example and you'll see again how it works. We have negative 3 plus, forgot this here, it should be 3i roots of 3. Okay? That's how they would write it. What 2 variables do I need to place something in a trigonometric form? What values are there? R and theta. What is the formula for computing R? Square root of a squared plus b squared. What is a squared? 9. What is b squared? How did you come up with 27? So square root of 3 squared is 3, and then 3 squared is 9, and 3 times 9 is good. When you square 3 roots of 3, you get that 27. And what is 9 plus 27? And what's the square root? So R is 6. Now I got to find theta. Theta satisfies the argument of tangent of theta is equal to b over a. What's your b value? 3 roots of 3 over a, or negative root of 3, right? Where is tangent negative? Which quadrants? 2 and 4. On my calculator, if I inverse the root of 3 for tangent, you know what you get? Then you better do it. I would do it in degrees and then convert to radians. 60. 60 degrees is going to be your reference angle. So therefore, what is the angle for theta? Which quadrant am I working in, folks? Am I in the second quadrant or the fourth? Look at the point. Look at the coordinate. Second quadrant, because you're back 3 and then up 3 roots of 3. Does everybody see that? So I could get rid of this one. What is that angle with a 60-degree reference angle? 120. Place it in the radians. 120 is what? Pi over 3. You have to take 120 times pi over 180. To simplify that fraction, you get 2 pi over 3. So we have theta is equal to 2 pi over 3. If you can write the radian measurement in terms of pi, I expect you to do so. If you can't, suppose it was tangent of theta is equal to 2. There's not a nice number for that, so you would just have to write the decimal in radian form. Okay? But if it's a nice number like 2 pi over 3, I expect you to come up with that. All right, so therefore the trigonometric form is r, which is 6, times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. That is the trigonometric form of that complex number. How about negative 2i? What is the a value? So I have a plus bi. What's the a value? 0. So if you want to calculate r is equal to a squared would be 0, b squared would be 4. What's the square root of 4? 2. That was easy. And then for theta, we have to solve tangent of theta is equal to b divided by a. What is b divided by a? Undefined. Where is tangent undefined? 0 and 360, that's where tangent is 0. Tangent is the same as slope. Where is it undefined? 90 and 270. So at which one is this point? Is this point at 90 or is it at 270? It's at 270. Okay, what is 270 in radians? 3 pi over 2. I knew it was at 270 because the coordinate is negative 2i. So it goes down the y-axis. So now I have my trigonometric form. 2 times the cosine, 3 pi over 2, plus I times the sine, 3 pi over 2. Now we did that one a little bit more quickly. Some of them you can do quickly. And when I see something like negative 2i, here's what I do. I just try to picture where it is. Think about it. What's the length of that segment? 2. What is the angle? 3 pi over 2. Done. Don't even need to set up the formulas. You can just see them and figure them out. Okay? So that's helpful. So your first task today in your assignment will be to write things in complex form. In trigonometric form, given the complex number. Now, if you cannot accomplish that, it is imperative that you come and see me. You cannot have success with the rest of the unit if you don't learn how to place things into trigonometric form. We're going to continue to practice placing things in trigonometric form, but we are also going to learn to multiply and divide these complex numbers. And it's really not that bad. But let's give the conditions. Given z sub 1 is equal to r sub 1 times cosine of theta sub 1 plus I sine of theta sub 1. And we're going to have a second complex number, which is r sub 2 times the cosine of theta sub 2 plus I sine of theta sub 2. All I've done is I'm just writing two complex numbers in trigonometric form. Now I'm going to multiply them together. It looks like it'd be really confusing. It's really, really easy. Then we know that z sub 1 times z sub 2 is equal to, if you multiply these two complex numbers together, we multiply the r values, and we add the theta values. suppose we want to divide them. Anybody want to guess what we do for our R values? We divide them. And what do we do for our theta values? Subtract. Kind of interesting about that is what we've said is really not that big of a deal. You multiply the R values, you add it, subtract the theta values, right? But it looks really complicated, doesn't it? Like it looks impossible. But yeah, but it's really easy what we're going to do here. You guys will see it. So we'll do one example here where it says find z1 and z2, or z1 times z2. That's what we're going to do right now. That's z1. That's z2. If I multiply them together, what do I do with the R values? And what do you get? 10. So, and what do we do with the theta values? Add them. Find common denominators. So we have pi over 4 plus pi over 3, or 3 pi over 12 plus 4 pi over 12. You add them together, what do you get? 7 pi over 12. That's it. Pretty nice, huh? Understand that those are points you want to get on the test. Those are points you want to say, yeah, at those. That's no big deal. Let's try z1 divided by z2. What do I do with the R values? Divide them. Instead of taking 3 pi over 12 plus 4 pi over 12, I get anybody else bothered by something you see up on the board? Can't have those negative angles, can you? What happens to the cosine of a negative angle? Just goes away. According to our even and odd identities. What happens to the sine of a negative? Right? Let's talk about DeMoivre's. DeMoivre's theorem lets us take a number like 1/2 plus 1/2 I and take it to the 10th power. Now, in the old days, how would you do that? Multiply it out. Yeah. Like, what do you think the probability level is of making a mistake in that? You think you have a higher probability of making a mistake or Cam Newton winning the MVP next year? Which do you think is a better probability? Yeah, I mean, the probability of Cam Newton winning MVP next year is 0. So, of course, you would have. Yeah, whatever. All right, DeMoivre's theorem. So, let's not make a mistake. Let's find the easy way of doing it. Okay. Okay, suppose we have a complex number, a plus bi, and you're going to raise it to the 10th power. 10 multiplied by 10 times, and what we can do is we can do this. We could take the trigonometric form, which is r times the cosine of theta plus I times the sine of theta. And this has something to do with what we did before. We multiplied things together, right? So when you were multiplying those trigonometric numbers together, what did you do with the r values? You multiply. So if we're taking it to power, what do you think you do? Yeah, we multiply r however many times it is. Oh, I said 10 up here. Well, I made a bowl of stupid up this, so this is to the nth. I'm sorry. Yeah. All right, so we're going to take r to the n. So we're going to multiply r n times. We'll come up with r to the n. And then if we add theta up n times, what's a shorter way of writing that? N times theta. So instead of writing theta plus theta plus theta plus theta n times, we just write n times theta. So we're going to show how to make this example right here, find 1/2 plus 1/2 I to the 10th power. We're going to show you how to make that rather simple. Okay. And if you said that you would rather multiply it out 10 times, then we'll just do that instead. We'll do 100 instead, because it doesn't take me any longer. If you're still not satisfied, then we'll go to the deck, okay? All right, that's what we're gonna do. We're just gonna break out trillions here, and we'll do that instead, because it doesn't take me any more time to do the problem. But multiplying that out would be ridiculous. So let's do it. How do we do it? We start by putting it into trigonometric form. We find r. How do you find r? What's the formula? What is a squared? 4th. What's b squared? It's a 4th plus 4th. Half. What's the square root of a half? Square root of 1 is 1 over the root of 2. Can't have a root of 2 in denominators. Root of 2 over 2. That's my r value. What other value do I have to find? Theta. Okay, so I've got tangent of theta is equal to b divided by a. What's b divided by a? 1. Tangent's positive. Which quadrants is tangent positive in? 3 and 1. Which quadrant is that point in? In 1. So I tangent inverse 1, and you get 45 degrees. Put 45 degrees at radians, and you get pi over 4. Because if you were to plot this, you would go over 1/2 and up 1/2. That would take you to the first quadrant. Thank you for asking the question. So the trigonometric form is root of 2 over 2 times the cosine of pi over 4 plus I sine of pi over 4. That's the trigonometric form. Now, what power are we going to take that to? The 10th power. Sounds difficult, but we just used DeMoivre's theorem. So the root of 2 over 2 times the cosine of pi over 4 plus I sine of pi over 4, all to the 10th power. Well, good old DeMoivre told us that that's not that big of a deal. We take the root of 2 over 2 to the 10th power. Now I'm going to cheat here because we'll have to simplify the answer. But instead of writing the root of 2, I'm going to write 2 to the 1/2 power. Everybody agree that the square root of 2 is 2 to the 1/2? Make life easier on me, trust me. Over 2 to the 1, and that's all being taken to the 10. Times the cosine of, what do I do to the angles? multiplying by 10. If you multiply by 10, what's 10 times pi over 4? 10 pi over 4, which reduces to pi over 2. Now, that gives you your answer. That gives you what 1 half plus 1 half I raised to the 10th power is. But we do need to simplify it, okay? We do need to simplify it. Otherwise, we'll have no idea how to check answers in the back of the book or anything. So let's simplify it. 2 to the 1 half to the 10th, what do I do to the powers? You multiply and get 2 to the 5th. And then 2 to the 1 to the 10th will be 2 to the... So we end up with 2 to the 5th over 2 to the 10th. 1 over 2 to the... And what is 2 to the 5th? Very good. I'll write it out, but then I'll erase it because I need to do it. So we got 2 to the 5th or 2 to the 10th. 1 over 2 to the 5th. Subtract my exponents to the same base. 2 to the 5th is 2 times 2 times 2 times 2 times 2. 3. You sure can use your calculator all you want. Better? Now, they won't let you leave it as 5 pi over 2. Does anybody know why? 5 pi over 2 is bigger than what? Yeah. Think about it. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So 5 pi over 2 is coterminal, or in the same position as what? Pi over 2. Now, if you didn't want to look at it graphically, you could just do this. 5 pi over 2 minus 2 pi, or 5 pi over 2 minus 4 pi over 2 is just 1 pi over 2. So instead of 5 pi over 2, they want 1 pi over 2. This is your answer in trigonometric form. I will be also asking you to express your answer in complex form, which is what I showed you at the beginning of class. Watch how it goes. It's no big deal. What is the cosine of pi over 2? 0. If you didn't know that, the cosine of pi over 2, right here, the coordinate is 0, 1, is cosine the x value or the y value? X value. So, you have, again, the cosine of pi over 2 is 0. Plus, what is the sine of pi over 2? 1. You're left with I. What is 1 over 32 times 0? 0. What's 1 over 32 times I? So that's the complex form. This is the trigonometric form. That's the complex form. They don't come out to be nice numbers. You write them as decimals. Look at the initial problem. Instead of find this by multiplying out 10 times. What do you get if you multiply it out 10 times? You get I over 32. So just think, all that written out, expanded 10 times, it all reduces to just I over 32. Now, you may say, big deal. What are we going to do on Monday? On Monday, you have to answer this question. What's the square root of negative 1? Good. What's the square root of I? No. Negative 1 times negative 1 is positive. What do you multiply by itself to get I? On Monday, we'll be able to show you this. we'll be able to show you what number do you multiply by itself 3 times to come up with -1 minus I roots of 3. And yes, I can show you the square root of I is on Monday. But right now, you don't have any clue, right? Monday's if you can make it through today's lesson, Monday's lesson, you could get an A on the test. These are the 2 hardest lessons. Time to practice. You have 20 minutes. Thank you, Mr. Gens, for giving us 20 minutes. Oh, well, you're welcome. You're such nice kids. So, you have these 2 pieces. That was yesterday's assignment. Today's assignment is rather lengthy because normally it's given over the course of a couple days. You have to work through these and practice them. For those of you who are here tomorrow, I will give you a checkpoint so we can practice it. For those of you who are here on Monday, which is everybody else, I will give you a checkpoint. We'll practice it. I made a note in my notes from last year. It said, insert more checkpoints during this unit. It also said, make the test easier. But I don't know if that'll happen. So